the quality distribution in your FDP, Faculty Development Program, in your agricultural meadows, there's organizing team. I thanks to organizing team to give this opportunity to deliver a FDP programs. And I'm sharing my slides, and I will discuss where it is application, as which distributions are most important in our agricultural, pharmaceutical, and medical purpose. And also, this is the very good opportunities to research, which is a main theme, including research topic also. This is very good topics and the quality distribution. Okay. Therefore, I'm sharing my screen. All of you seen? It is visible?
Yes, sir. Yes.
Okay. So that is the second day, quality distribution functions. And so first of all, I don't know the participants which backgrounds are related to this faculty development program, but I believe that some of these the participants are knowing about the quality and statistics. Some ideas also is there, and most of the related to these discussions. So what is quality distributions? Quality distribution describes the value of random variables, right? So first of all, the random variable, how to count the random variables? So random variables, which is defined by mathematically, it is x is a function of real numbers to each possible outcomes. Which types of outcomes? Because those are the different fields. Because outcomes from the agriculture fields, from the pharmaceutical field, from the medical field, so many fields are there. But I have discussed only 3 fields. That's why I'm saying 3 different outcomes from the quality distribution. In agriculture, depends on variable of like rainfall, yield, pest population, follow quality pattern. Okay. So here, actually for this agriculture, crop yield, suppose crop yield in these cases, if X crop yield agricultural involve uncertainty due to weather, soil condition, pest and market price, right? So here distributed help analyze the using statistical method, how to analyze and which will be the better result using by new trained artificial neural network or machine learning, and it follows farmer and researchers to predict possible outcomes and better decision, which will be the better. First of all, if x, suppose by mathematical term, I am suggesting x equal to, because yield of rice, okay, per hectare, it is x, the random variable x we take. And this yield of rice depends on the rainfall, fertility, and temperature. Okay, that is also quality. Because if rainfall will be high, so therefore no rice will be produced, and depends on this temperature, because different monsoon semester and winter semester and high temperature, it is lost the rise also. So this varies also unpredictably, right? Similarly, another, the uncertainty event, suppose X is the random variable or the insect of plant per plant, number of insect per plant. So what is probability? Their probability distributed changes due to environment and biological factors. This depends on these biological factors. And another is the same prediction depends on the soil. Okay. And first, I have suggest the likelihood of different outcomes. By statistical, what is likelihood of different outcomes? Likelihood that mathematically expression as also the probability distribution, where each possible outcome is assigned a probability. For example, I am saying one example. If rainfall, rainfall is low, medium, and high. And suppose when rainfall is low, if I calculate the probability, if it is 0.2, and when it is medium rainfall, if probability is high, so therefore the maximum rainfall is most probable scenario. Similar case, when the rice yield, that is per hectare, and that produces the rice in the field, that's 2 ton, 3 ton or more, and their quality I have distributed. If the probability is high, so therefore most likelihood outcomes will be higher probability, depends on this higher probability. That is one type of examples in this agricultural field, where it depends on rainfall, yield, based population of this probability pattern. Next slide. You see, I have distributed so many plants in here, but we don't know what will be the outcomes. After using these inputs, inorganic fertility, atmosphere, deposition, biological, sediment, organic, water irrigation, crop. So after that, seeds are depends on these input functions. And outputs you are showing in my slide: harvested crop, pest or disease damage, okay, water or soil erosion, biological resource. Okay. So this is also called a soil and crop management step. And these are quality distribution in the agriculture field. This quality distribution helps in understanding and predicting variability in agriculture, such as crop yield, rainfall, germination, and pest. Okay, because these are the criteria when the probability are depends on these criteria. If rainfall is high, so therefore quality will be low, so therefore good results not coming. And germinations will be depends on so many parameters, okay, for to develop our agricultural field. And this distribution, quality distribution, mainly these 4 distribution are distributed in our topic. That first of all, binomial distribution, Poisson distribution, normal distribution, gamma, and exponential distribution. Okay. So here, binomial distribution know the which one is successful and which one is failure, right? Because depends on success and failure. But we don't know use the seeds, which seeds will be success and which seed will be failure. Using this graphical representation, I am showing which is successful and which is failure. And Poisson distribution, that is mostly for the pits but insect, depends on the insect. So many, because when eta n tends to infinity, because depends on this insect. If insect is uh, insect in model the number of bees in the field and higher number of insect, so therefore destroy the uh, plants. And normally distributed, the statistical term that is distributed as a normal distribution, this applied to crop yield and plant growth when it is low, average, and high. And this averaging value by mathematical I am showing next slide. So when depends on this the averaging values when it is low and when it is high. Okay. And this is gamma and exponential distribution. This depends on this parameter rainfall and drought analysis. Here, this is a summarize. The quality distribution is an important statistical tool, and the data analysis, it helps to researcher to understand and predict in agriculture processes and depends on crop yield, rainfall, germination, and pest population and soil characteristics. And first of all, I am defining binomial distribution. Here, this binomial distribution to studies of seed germination, where each seed either germination or fail. It helps determine the quality of a certain number of successful germination in a fixed number of seeds. So which one will be success, which one will be failure, depends on the binomial distribution. Okay. Next is Poisson distribution, because when there are so many insects are affecting in the crop within the specific time or area, this helps in pest management and crop protection planning. Another is the normal distribution, which is showing in the graphically. The normal distribution is widely used to analyze crop yield, plant height, agriculture, and many natural agricultural data flow, bell-shaped distribution, because this type of distribution are called a bell-shaped or normal distribution around the mean value. And other distribution, that is exponential and gamma distribution, this is sudden rainfall pattern. This is depends on the climate, and this analyzing agriculture data, predicting output, managing risks, and improve farmer strategy, thereby supporting efficient and sustainable agriculture practices. Okay. Okay. Next, important in agriculture, in the quality distribution. Which one is the important? Because here helps in decision making under uncertainty, means that is the quality distribution. Improve crop planning. How to improve the crop planning? That is also the measure of the soil and which types of crop you are using. That is improve of the crop planning. And next step, support agriculture research and policy planning. Without policy, the plan not successful. That's why agriculture research, first you planning how to develop the agriculture research and reduce economic risks for farmer, because this is most important for the farmer. If the economic risks, always it will be happen to the economic risks, but it should be reduces. And first of all, the rainfall modeling for this agriculture land, this is depends on the rainfall model. The rainfall amount every year, that is depends on the rainfall. That is also depends on this one type of probability distribution, and these distributions are distributed as normal distribution. Okay, and this help estimate drought risks and irrigation requirements. Again, the crop yield prediction, that varies to weather, soil fertility, fertilizer, and pest, because these types of crop depends on this weather, soil, and fertility and pest. This yield depends on this normal distribution, right? Here, expected production and risks of for failure. Okay, pest and disease analysis. Here, because so many insects means by mathematically when n tends to infinity, the number of insects when appear in the crop, so this is destroyed in the plant. So these cases we using the Poisson distribution. Here, this determine the quality of pest outbreak. Next is seed germination analysis. Because here we are using the binomial distribution, because of which seeds will be application for the plant is grow or plant will not grow, plant will be destroyed. So this is depends on the success or failure. These seeds germination success or failure can be modeled using binomial distribution. Useful in seed testing laboratory. First, check the laboratories which seeds will be appropriate for this plant. After that, you treat it as a agricultural purpose. But most important, after production, this will be sell in the market. So that's why agricultural prices fluctuate due to supply and demand. This probability model help predict to price variability. So help farmers decide when to sell or store crop. Okay. Example, because when the rainfall is so 70% quality of the rainfall between 800 to 1000 millimeter, farmer can select crops suitable for this rainfall. This reduce crop failure risks. Okay, but this agricultural quality distribution, where it is the advantages: improve farm planning, help in crop insurance calculation, support sustainable agriculture, enhance scientific agricultural research. Because nowadays, these types of research is very most important using the quality distribution in the agricultural field. Okay. Because if you get the data and after that you using the data analytic and you got the result using this statistical data, and which one will be improved in our agricultural field. Conclusion for these cases of the agriculture field: quality distribution is an important statistical tool in agriculture. It helps understand uncertainty, and support better decision making. Application include rainfall prediction, yield estimation, pest control, and market analysis. So these are the conclusion, because if the rainfall prediction, if you predict the rainfall in this year, the rainfall prediction and yield estimation and pest control, mean insect control, obviously the field, so, and price depends on this market price also. And this is normally distributed. I'm showing graph because this x-axis the yield deviation and this is the normal distributed graph. Use this model crop field or plant height, and this is because number of insect, so many insect destroy the plant also. So when it will be distributed, if it is number of insect per plant, it is depends on this 2 to 4. So therefore, the plant will be destroyed. So quality will be high. In this graph, it is showing this probability is high when insect are 2 to 4 in this line, number of pest. So therefore, quality is 0.2, high quality, the pest will be destroyed. To help the predict quality pest outbreak. And this is binomial distribution, which one is the success and which one is the failure. Number of seeds that successfully germinate out of total plant. In this graph, it is mentioned. Okay. Next tuple. Hello.
Sir, please continue.
Okay, no problem. I'm continuing. Next is pharmaceutical field. Quality distribution in the pharmaceutical field, where it is application and which parameters are most important in the pharmaceutical field in the quality distribution. Here mentioned that a quality distribution describes how qualities are distributed over the value of a random variable. Already I have discussed which types of random variables depends on a function, okay, and the real valued function. In this pharmaceutical industry, quality distribution are used to analyze, because this pharma drug manufacturing variability, because this pharmaceutical field, they are manufacturing the drug. Clinical trial outcomes, drug stability, side effect occurrence, quality control of medicines, and graphical representation help scientists visual uncertainty and variability in pharmaceutical processes. And you see this industry, the process of the pharmaceutical field, how to manufacture the drug in the pharmaceutical company and where it is used first. You see, first of all, drug development process, discovery and development. After that, they are using in these types of animals. Okay, first they are using the drug. After that, clinical research, they are predicting which one is the better. Then it is number 4, regulatory review. After that, post-market safety monitoring. Okay, because most important is the data analytic, which medicines are means marketing, which medicine are so many marketing. So that's why clinical trials is most important in the pharmaceutical research. In this research and in this distribution, that depends on drug development, clinical trials, and quality control. These help analyze to variability in biological response, drug concentration, and adverse effects. If it is adverse effect, so therefore this will be the failure cases. When success and failure cases, obviously, which distribution will be using the binomial distribution. And by this probability distribution, or pharmaceutical scientists can make reliable prediction and improve the safety and effectiveness of this medicine. Our common distribution is the binomial distribution because each patient either responds positively to a drug or does not. It helps determine the quality of a certain number of successful treatment among the group of patients. Right? So that's why here using the binomial distribution. Next, Poisson distribution. How to use the Poisson distribution? Because such as the adverse drug reaction and side effect occurring within the specific period in hospital or during drug trials. Okay, these cases are using the Poisson distribution. And the quality distribution, that is most important distribution, is the normal distribution. Is widely used in pharmaceutical studies to describe drug concentration in blood, plasma, tablet weight variation, and measurement error. Many biological and experimental data follow a normal, making it useful statistical analysis and hypothesis testing. Okay. Another is exponential distribution. This used in the to study the time dependent. This exponential depend on the time because in this medical line or pharmaceutical line, time is the most required for drug elimination from the body or the time between drug reaction. This is most important because if you to take drug within 5 minutes, this is not, because after 8 hours, if we take the drug, it will be better for this study. In addition, quality distribution are used in pharmaceutical quality control and monitor production processes. Okay, ensure correct doses in tablet and capsule and maintain consistently drug quality. Okay. That is, this quality provide essential statistical tool and analyzing experimental data, evaluating drug effectiveness, ensuring quality control, and improving decision making in pharmaceutical science. And these are the scenario for this quality distribution in the pharmaceutical field. There are different types of quality distributions help in analyzing and predicting agricultural outcome. Similarly, the pharmaceuticals field. These quality distributions are very much important. And here, binomial distribution, this analyze drug success rate, depends on the success rate, which drugs will be succeed in the market. So that is depends on this binomial distribution. This Poisson distribution model, the number of side effects from the drug. So when these types of side effects are occurring in any human bodies or any other bodies, so these types of distributions are using as a Poisson distribution. And normal distribution used for drug concentration level in blood. Their blood is most important, concentration level of blood. These types of cases, we are using the normal distribution. Okay. An exponential distribution, that is depends on the time between drug, because when you take the drug and you have given some time and check if it is recovery within the time, so this time will be most important for this exponential distribution. Another, the quality distribution in the medical field. Medical field is also important in this quality distribution, and this important in the statistical tool, and the uncertainty and variability in health related data. It helps medical researchers, healthcare professionals understand pattern in patient outcome, disease occurrence, and treatment effectiveness. Because medical field depends on this patient outcomes, disease occurrence, and treatment effectiveness. These different types of qualities are distributed in binomial distribution, is used in the clinical trial where each patient either responds to a treatment or does not respond. Because these cases, when there are success or failure, those are response and those are not response. When these cases are using the binomial distribution, it helps determine the quality of a certain number of successful treatment among the group of the patient. And the Poisson distribution used this model occurrence of rare medical events, such as the number of new disease cases or the number of patient arrival in the hospital during a given period. And normal distribution using widely using the described biological measurement such as blood pressure, cholesterol level, body temperature, and height. Many medical data sets follow a bell-shaped curve, means normal distributed curve, centered around the average values. In conclusion, quality distribution helps in analyzing clinical data, predicting disease pattern, evaluating treatment effectiveness, and improving medical decision making, making them essential tool in modern medical research and healthcare. These are the quality distribution in the medical field. This is important, analyze uncertainty and variability in the health related data. It helps medical researcher and healthcare professional understand pattern in patient outcome, disease occurrence, and treatment effectiveness. These are the most important tools for this quality distribution in the medical field. These are the patient outcome, disease occurrence, and treatment effectiveness. And this distributed binomial, Poisson, normal, and exponential. Binomial means which medicines will be succeed, rate of success and rate of failure in the clinical trials. This is a binomial distribution. And the rare medical event are occurred, this is Poisson distribution. And when describe blood pressure, cholesterol, body measurement, height, this is normal distribution. And disease depends on the time between medical events, that is depends on this exponential distribution. Okay. Now, I am giving some mathematical output, how to calculate by using by mathematics the quality distribution. Because quality distribution as a function is a list of qualities of the simple outcomes. Because here number of heads in two tosses of a coin. Because sample space S means here that is total S means 4. Because two tosses, because any coin, this is two sides, head and tail. If it is two coins, head and head tail. So therefore, out 4 is there. So head outcome of two tosses. So first tosses head and second tosses also head. So this quality will be 2 by 4. And simple cases for quality simple outcomes, quality lie in between 0 less than equal to quality of the outcomes y less than equal to 1. And also when the quality simple outcomes summation of quality of y, always this will be 1 summation. Total number of quality, this will be always 1. You see, this quality distribution, there are two cases. One is discrete case, another is continuous case. Which one is the discrete case and which one is the continuous case? But here, so many distribution are there. Bernoulli's distribution, this response yes and no responses. Binomial distribution, where it is success and failure, sum of the Bernoulli's response. Negative binomial means number of trial to kth event. Poisson distribution, point in given space. Geometric distribution, number of trial until first success. Multinomial distribution, multiple possible outcome for each trial. So these are total at the discrete distribution. But in our cases, only we are using only the binomial distribution. Here, this binomial distribution, pi, here indicate pi is the succeed and failure means 1 minus pi. And that mathematical term, we are using the binomial distribution, that is P of y equal to factorial n by this term, pi to the power y 1 minus pi. This is the mathematical term. Here mean is defined as a mu, that is n pi, and sigma equal to under root n pi 1 minus pi. That is the standard deviation. That is the mathematical model of this binomial distribution. And these are the discrete case. I have seen, because already we define summation of P of y equal to 1. When pi means succeed equal to 0.5, and you have put P of y, you know these formulas, factorial n by factorial y, factorial n minus y, pi to the power y, 1 minus pi to the n minus y. If you substitute the value and after calculating and then summation, you get the result is, summation result is 1. Here also, when pi is equal to 0.25, the summation result is 1. In these cases, I have given example for different n equal to when 5, 1, 0, 1, 2, 3, 4, 5. And you see, for these cases, when pi is equal to 0.5, you see for these cases 2, 3 are the quality 0.3, because 2, 3 cases and there are 2, 3. When y is equal to these 2 and 3, because this is 0.3, 0.3, this quality is high. Other thing quality is not high, right? Again, when pi means succeed is 0.25, here you check the when y is equal to 1, here the quality is high, 0.3955. And for these cases, when pi is equal to 0.1, when y is equal to 0, the quality is high, means 0.5. And similarly, when pi is equal to 0.05, here quality P of y equal to 0.7. This point is high. And these values are graphically described in this binomial distribution for these cases when n equal to 5. But when n equal to 50, that is the bell shaped are this distribution function are distributed. And the binomial distribution, this is the observed value, the blue, and these are the theoretical values, and these are the head. We see when 50 times at the experiment is repeated 50 times in the graphical representation, the probability of these things. And you check here the quality P the two dice are thrown. Two dice means because dice means are thrown, number of waves shows the counted random variable capital X, the simple experiment, and it is repeated 50 times. You see in this blue line, when px less than equal to 8 means this color. So px less than equal to 8 means including 8, 2 to up to 8. The frequency total 2 to 8 means 33 by 50 because the probability px less than because 0.66, and this frequency, this one relative frequency, and this red line means 4 to 10, line between this 4 to 10, this line, and that is 4 to 10, 4 to up to 10, this line are the red line, and the blue line, this one, x greater than equal to 6 means 6 to 10, and total probability 4 to 6 to up to 10 if you add this one, and you have to find out the probability px greater than equal to 6. So that is the one type of example how to define the p 4 less than equal to x and 4 less than equal to for 34 by 50, how to calculate this probability line between 4 less than equal to x less than equal to 5. And these are the another types of example. A typical method, vegetation sampling data. It seems are randomly dispersed. The count could be modeled as a Poisson distributions. Okay. And this Poisson distribution, that is the mathematical expression of the Poisson distribution, P of y equal to lambda to the power of a factor I e to the minus lambda. Here, mean and variance are the same because this one also lambda and this one also lambda. Mean and variance are the same in the Poisson distribution. Okay. And some example. And next is continuous distribution. Previous was the discrete distribution, and another is the continuous distribution. The continuous distribution, that is depends on normal distribution. The normal distribution foundation for much of statistical inference, log normal distribution, gamma distribution, chi-square distribution, F distribution, T distribution, Weibull distribution, extreme value distribution. But most of the cases, we are using the normal distribution. And probability density function, which is defined at f of x, and the mathematical continuous distribution probability distribution function when px less than equal to x naught, it is defined minus infinity to x naught fxx equal to dx. And for the zero probability of occurrence x naught to x naught fx x dx equal to 0, because if it is x equal to x naught, because this one you substitute when x equal to x naught. So when x equal to x naught, this will be x naught to x naught. This probability is the zero probability occurrence. This is called the zero probability occurrence. And these are the standard normal distribution. Yeah, the notation, the normal distribution, suppose x is the normal distribution with mean mu and standard deviation sigma, and it is denoted by capital X equal to this normal distribution mu as sigma, where mean equal to mu as sigma is the variance. And basically this normal distribution that is depend on 0 to 1. That is a standard normal distribution. This is a standard normal distribution. Here, because these standard normal distribution are defined z is equal to x minus mu by sigma, and cross multiplication sigma z plus mu equal to x. Okay, you have calculated after that. So why these normal standard distribution are important? Because in this way, the quality of any event of a normal random variable with any given mean and standard deviation can be computed from table of the standard distribution. You see, already I have calculated that this is the normal distribution and z is equal to n01. This is the standard normal distribution. And after this calculation, we get x equal to sigma z plus mu. And when we have calculated when x equal to less than x naught, how to calculate? Substitute these x values in sigma z plus mu, and sigma z plus mu less than x naught, and sigma z less than x naught minus mu, and z equal to this one you calculate. And then calculate this probability z less than these things. This probability can be found in the table standard normal probabilities. Because in the table already the standard normal distribution, the values are given for this table, from this table. And these are the important relationship when probability z less than z naught. So this can 1 minus p z greater than z naught. This probability are the complementary event. This is called a probability of complementary event. And when z less than, here most important, that is minus z naught, equal to p z greater than plus of z naught. Okay, because this symbol when it is changing greater than, this symbol also plus. This is called a symmetric of the normal distribution. And always I am indicating the table. For this table, we are calculating by mathematicals find p probability of 2 less than x less than 4 when normal distributed are 5, 2. 5 means mu and standard deviation is 2. And we have substitute the values mu and sigma, 5 and 2. And when x equal to 2, because you have to find p 2 less than x less than 4, 2 less than x less than 4, that is px less than 4 minus px less than 2. And px less than 2 by symmetric, and from this table, and px 4, put these values by the symmetric minus will again. And after that, we have calculate quality of 2 less than x less than 4. And this result is 0.2417. And properties of normal distribution. Properties, because these are the standard properties of the normal distribution. The 68% of area under the curve, that is defined mu plus sigma. And 95% of the area under curve, because this is mean, that is the standard mean, this portion, this is standard mean. And this is mu minus sigma, this is mu plus sigma. Another is mu minus plus 2 sigma, mu minus 2 sigma. And these portion are 68% area under the curve, mu plus minus sigma, and 95% area, mu plus minus 2 sigma, and 99.7% area under the curve between mu plus minus 3 sigma. Okay, this is the standard normal form. And using the standard normal form, the another quality problem using by standard normal distribution, we have to find out the values of the standard normal form using by symmetry, because quality of z less than minus of this thing means already you know, using by symmetry quality of z greater than 1.83, and using by standard normal form we have know the values from the standard normal table and substitute these values. Okay, and so many problems are described here. These are the different types of problem, because when normal distribution 100 comma 10 means mu equal to 100 and variance equal to 10, what will be the result of the normal distribution? And this is the indicate the standard normal distribution z is equal to x minus mu by sigma. And decomposing event, and these are the examples. Quality, this is the practice, and how to get these values of this quality distribution. From this table we have to find out the values of the normal distributed. Okay, these are the normal distributing values at the quality distribution, the critical value from this table. Okay, thank you. Any questions from